I'm going to give you an introduction to HumanIK, focusing on the most important features you have to understand to start evaluating and using the product. HumanIK is a C++ API to create, modify, and reuse character animations in runtime. It is also used internally by MotionBuilder and Maya as a high-level controller for authoring characters animations. HumanIK is a big toolbox with plenty of features, but today I'm only going to speak about the two most important features you have to know. First of this feature is retargeting. I'm going to cover this in the second part of my presentation, but right now I'm going to talk about the most important feature, that is FullBodyIK. So what is FullBodyIK? First, you need to understand what IK is. What you see here on the screen, this is not IK. This is FK data coming from motion capture source. The problem with FK data is it is heavy in memory and cannot easily adapt to the playback environment. On the contrary, IK is far less memory consuming and is meant to adapt to the playback environment. The principle of IK is you only provide target positions and orientations for certain parts of your body to get reached, and then there is a solver being called that computes how your FK pose should be adjusted so that all the target positions get reached. These targets, we call them effectors in HumanIK. Effectors are displayed by red and blue spheres on the screen. There are effectors for the legs, for the hands, the head, even for the fingers. And the whole promise of HumanIK is it will quickly find the best solution for all the active effectors to be reached. For example, if I grab the left hand effector and move it in the scene, HumanIK will automatically compute the transforms for all the character arm joints from the wrist to the shoulder so that the hand effector gets reached. This obviously works for all body parts, and HumanIK is able to reach both target positions and orientations. What you see here is simple mathematics, and most of you guys perfectly know how to write these kinds of IK constraints. But usually the in-game setup is far more complex, and these two-bone IK algorithms are not good enough. And this is where FullBodyIK comes in. FullBodyIK is the ability for one effector to engage the whole body of the character and not only the limbs it belongs to. For example, if we move the effector to grab the cube on the ground, HumanIK FullBodyIK solver will automatically straighten the character arm, bend the character knees, and curl its spine. So with very few inputs, we get some pretty good results here. Obviously, you do not choose between IK and FK. You usually use both of them at the same time. HumanIK is able to smoothly blend these two animation data. For example, in this shot, we play the same FK animation data on both characters, but the character on the right is using HumanIK FullBodyIK solver for its left hand and left foot to stay pinned on fixed locations. You can imagine how useful this can be when you need your character to grab a doorknob or a weapon on the ground, or to stick its hand on a horse or a dragon he is riding. Floor contact is another type of constraint HumanIK implements. HumanIK is able to plant feet and hands of characters on the ground. HumanIK supports 3 floor contact models: a low-definition model that approximates a good-looking contact on the heel, a medium-def model that properly aligns the whole foot plant with the ground slope, and a high-definition model that even takes into account fingers and toes. Here is how a good integration of HumanIK looks like. This is how HumanIK is used in Assassin's Creed. When Ezio is climbing on the buildings, there is some nice FK animation being played, and this animation gets pinned on the prominent parts of the wall using HumanIK FullBodyIK solver. This increases a lot the integration of the character in its environment. There are plenty of other uses you can think of. At any time, you can pin any part of your character on any static or moving object in your world, including creatures or vehicles. The second important feature you need to remember is retargeting. Retargeting is the process of using a forward kinematics animation recorded for a given source character to control the movements of one or more different target characters, which may have very different proportions, scale, skeletal structures, limits of motion, level of detail, etc. These characters are sharing one single animation data coming from the blue character. Note that the look and feel of the original animation is preserved on all characters, You all understand this is a clever way to spare animator and animation resources. Instead of creating one animation bank for all character types in your game, you can share the same animation bank for all character types. The HumanIK retargeting algorithm is fast and accurate. It is an optimized version of the retargeting algorithm used internally in MotionBuilder to map actor motion data on arbitrary characters. Tons of artists in the world contributed to this high-quality retargeting. It is actually important to emphasize on the synergies between HumanIK and MotionBuilder. Both pieces of software share the same terminology and similar technologies. This is so true that we usually recommend users to prototype their IK in MotionBuilder before writing any C++ code in the runtime using HumanIK. Actually, most of the character setup of HumanIK, you can do it using the nice-looking MotionBuilder GUI and export it as a binary data file to be loaded in the runtime. This is far easier than doing the same character setup in C++ code. Please watch our HumanIK integration video to learn more on this. Also, when you buy or evaluate HumanIK, you get access to the exact same version of the MotionBuilder plugin so that you get the exact same solving in both MotionBuilder and your runtime. So basically, what you see in MotionBuilder is what you get in your runtime. We even got further with the latest version of HumanIK, that is HumanIK 2013. You can now use MotionBuilder to debug IK behavior. The runtime is able to dump data that gets converted into FBX and that you can reload and analyze in MotionBuilder. This is nice, since it makes it possible for artists to help programmers debugging their IK behaviors. Here are some few projects we've been recently working on. These pictures come from the latest Need for Speed, the run. You can see here how HumanIK Retargeting and HumanIK FullBodyIK solver are used to handle quite tight character interactions during cutscenes. HumanIK shoulder solving has been improved for doing this. We support up to 3 shoulder joints for better looking animations. We all know that having strong interactions between characters of different sizes is hard to manage from data and code point of views. HumanIK can help you on this. These are pictures from Electronic Arts MMA game featuring a very sophisticated combat system using both HumanIK Retargeting and HumanIK FullBodyIK algorithm. HumanIK guarantees fighters from different proportions can punch and grab each other in a realistic manner. To conclude this session, please read the following statements on the screen. If you recognize yourself in any of the following statements, you should definitively take a closer look at HumanIK.